We're recording. All right. Welcome everybody to your introduction to Python, the most awesome programming language in the world, and also your introduction to computer science, which I know a lot of you are pretty nervous about, but well, it'll be difficult. So I don't want to tell you it's going to be easy, but you'll have a lot of support. It's really interesting. A lot of these things will make no sense, and then they'll click, and then once they click, it opens up an entirely new world. Like it'll go from you're watching the Matrix. It's just green letters flying down the screen, and all of a sudden, you'll understand. You'll be able to see the lady in the red dress in all the machine language. Really, computer science is it's a lot of fun once you get to know it. Once you start understanding how these things work, and by these things I mean computers, algorithms, from hardware to software, and you can start to see throughout history so many smart people have done some really clever things, and it's all right there. It's all very simple and elegant once you lay it out, and that will help you write better code. That's something that I actually struggled with for a long time because I'm sure you've all had this experience where you're writing code and it doesn't work and it doesn't work and it doesn't work and it doesn't work, and all of a sudden it works, right? And then you're like, great, I'm done, and then you move on. And that's a pretty common coding experience, and that's something that I still do. But there's code that works, and then there's code. I guess there's code that works now, and then there's code that will work in the future when you get more users, when it's under higher stress, when you have different inputs that maybe you didn't expect, and that's where computer science really helps. Computer science will help you find bugs when you're looking at your code and it's broken and you don't know why it's broken. Computer science will help you. When you're looking for bugs, you're kind of like a detective, right? You're gathering evidence, you're running tests, you're trying to replicate your bug so you can fix it. And sometimes you just don't know, you don't even know where to start. Well, computer science will help you do some forensics. You'll be able to see, oh, this is happening. Maybe it's something to do with the memory, and then you can know to start looking in your memory, and then you can say, okay, I have this function is running in big O of n cubes. That's probably going to fill up my memory super fast. Oh, I probably have a memory leak. Bam, fixed it. Things like words like big O may not make sense to you right now. Things like memory leak, you've probably heard, but maybe you're not sure what it means. But by the end of your computer science tenure, you're going to know what all of these things mean. You're going to hopefully all be masters of this. So before we get started, before we jump into Python, let me start by introducing myself. For those who missed our kickoff last week, my name is Brady. Hello. Brady, like Tom Brady, greatest quarterback of all time, which I'm very happy about because I used to introduce myself as Brady as in Brady Bunch, but Tom Brady is much cooler. So I started coding about 15 years ago in 2003 when I went to college at UC Berkeley, where I studied electrical engineering and computer science. At first, I was going to go into robotics until I failed my upper division robotics class, and I decided to go into computer science instead, where I focused in graphics. Before that, I went to art school, so I was actually a music major, and I focused on computer graphics because I thought that was a good blend between sort of the code and the arts that I was really interested in. So my first job out of college was at Pixar, where I worked for 6 months until I realized that I really liked Pixar. At that time was about over 1,000 people, and I realized that I really wanted to work in a smaller group on a smaller team. So I left and I decided to pursue a startup in educational games. So I worked as a tutor for about a year, and I got into grad school at Stanford, where I studied in the the School of Education in the Learning Design and Technology program. So I got my master's degree in that. And after that, I did a startup in making an educational game. And we were in some schools in San Jose. That went on for about 3 more years. While I was there, I was also a game designer and prototypist at Disney, working on social games. And after that, my startup collapsed for a lot of reasons, some of which were our faults, some of which were not our faults. And after that, I went to a company called EdSurge, which does educational technology reporting, where I was a full stack Ruby on Rails developer. And I worked on that for 2 years. Then in 2016, my girlfriend got into med school in Cleveland at Case Western. So I moved there with her. So that's where I am now. I'm in Cleveland. And since then, I've been doing a lot of remote freelancing, doing all kinds of different jobs. I worked on a dental appointment scheduling app. I did the back end for a mobile bingo game with live games, sort of like HQ, if any of you have played that. What else? I did a travel agency's CRM software. And then I started here at Lambda School last month. So this is my first big class I'm teaching. I'm sure I'm going to make a lot of mistakes, so please give me feedback. I'm always willing to listen. I'm always willing to try to improve. And yeah, that's me. As you can maybe tell, I've had a lot of different kinds of jobs. I've done everything from embedded Linux on hardware to computer graphics to game design and development, full stack web, front end, back end. I've done all kinds of stuff. And really, the one thing that I found over all my career is that I think the more things I do, the more I started to appreciate computer science. Early in my career, I went to college. I took a lot of computer science classes, and I learned it, and then I didn't really use it that much. I thought, like you learn all these complex algorithms, and then when you get into, like, for example, if you're building a website, you're not really writing an algorithm, right? Like you're saying, okay, we're putting this button here, we're making a div here, we're putting this content here. Underneath the hood, if you're on back end, there's a lot of algorithms going on, but really you're just saying, oh, give me all of the usernames, right? Like you don't care how it finds it. You don't care. You assume that someone who is very smart has come up with an efficient algorithm to get you all of those users. And you're not really worried about how it does it. And that's usually enough to get by. And a lot of boot camps, for that reason, a lot of coding boot camps don't teach computer science at all. Again, later in my career, and especially as I've gotten to more senior positions, I really started to appreciate how much computer science gets you. Even if you're not writing algorithms, it's important to know what's going on underneath the hood. For example, when you index a column in a database, you may know, okay, there's a little bit of cost, but it makes it faster, I guess. Like, what's going on there? What does it actually mean to index a column? It makes it easier to find, but what are the costs? Like, if it makes it faster to find, why don't you just index every column, right? Well, with computer science, you understand, oh, okay, they're doing, you're indexing up front, which gives you a log n cost, and in return for a log n seek, as opposed to a constant time insert and a n seek. Again, that probably doesn't make much sense to you right now, but it will make sense as we go along further. So that was a lot. Before we get into Python and into some coding, do you guys have any questions for me? Any questions about computer science? Anything at all? Silence, crickets. Please, please, please ask questions during lecture. Otherwise, I just feel like I'm talking to myself. There's 54 of you in here. Why is Python my favorite? Awesome question. I'll get into that very, very shortly when as we start looking at Python. Let me share my screen as we're doing this. What benefit do you think front-end developers can gain from learning to write lower-level code? That's a really good question. One of the segments that we're going to be talking about is computer architecture. And when you're dealing with front-end, you're dealing with people's computers. And especially on web, and especially on mobile, you need to know what are the limitations. So a lot of smaller phones have memory requirements, and you need to, it's good to be able to understand when you're stressing the memory, when you're stressing their processors. If you're doing very processor intensive operations on the front end, you can drain people's batteries, things like that. It's good to know, like when you're caching, we're talking a little bit about dynamic programming, which involves caching, and you want to know what does it mean to cache something? How does it work? What are the costs and benefits behind that? Also, in general, it's code. A lot of things in code are universal, where you should just be able to look at your code and be able to write the most clean and concise code as possible. And sometimes that means writing less lines of code, but sometimes it doesn't always mean writing less lines. And you'll understand what it means to analyze code and benchmark the efficiency. And that stuff is universal. What's my favorite compiled language? That's a good question. I've done, I guess C and C++ are cool, which you're going to be doing later on. That's cool because you all of these fun stuff that Python does for you, C does none of it for you. So you really have to know exactly what's going on, and it really helps you understand what's going on when you write, when Python does these neat little functions. Python for machine vision or C or C++. I haven't done much machine vision. I know that a lot of AI is done in Python, and there's a lot of libraries for Python. When you're doing high-level things in general, I think Python and other high-level languages are pretty useful, just so you don't, because a lot of the stuff that you're trying to write, someone has probably written it before. So you usually want to go for something with, you want to go with a higher level language with a lot of packages you can just import. Do I have advice for making games? Check out Unity. Unity is really easy to use. Java's cool. I use C# a lot. I use C# in Unity because and Unity C# is very, very similar to Java. But Mark, just jump into it. Just start making games. You can make really small games, and it's not too bad. Don't spend too much planning. Don't say I'm going to make a huge MMO for your first game. Just make like a little tiny game, and then build on top of that. Too many people get caught up in trying to make these huge things and just get stuck. Do I have advice for making AI? Study algorithms. AI is all about algorithms. Study your computer science. AI and machine learning and stuff is all about writing efficient code, so you can go through tons and tons and tons of material. And you need to, if your algorithms are not on point, then you're going to really get stuck. What is my database preference for Python? Python works with well with Django. I don't know if that's your question. And if you're using Django, then Django, you can do different things. You can use SQLite. I tend to use Postgres just because I like Postgres. It's very powerful, and I know it can do everything I need it to do. I also tend to like relational databases. I haven't done too much with NoSQL databases. Yeah, C# is a lot more established in Unity. So when you write JS in Unity, JavaScript, it's actually not JavaScript. It's something called UnityScript, which has JavaScript-like syntax. But when you compile it, it gets converted into C#, and then it runs the C#. So in general, anything you can do with JavaScript and Unity, you can do in C#. and probably better and more efficient. Are you going to cover R when studying Python? No, I don't think R is part of the curriculum for this segment, but who knows? It might be sometime in the future. Awesome. I like these questions. I like having a lot of questions. Cool. So let's get started with some Python. For this week, all of your Python assignments are going to be in this GitHub repository. I'll throw this in Slack. In the Lambda School, on the Lambda School account. So here, there's a lot of nice links. There's some instructions for getting Python installed. There's also this neat thing about installing Python. That so your assignment, the biggest part of your assignment today will be installing Python on Python 3 in particular. But look through this page. There's a lot of cool stuff. There's also this JavaScript Python cheat sheet, which we'll be talking through a little bit. But yeah, so why Python? That's the first question. Why are we learning Python? You already know JavaScript, right? JavaScript is very similar to Python. So why do you need to know Python if you already know JavaScript? Pretty much anything you can do in Python, you can also do in JavaScript. There's pros and cons to each. So again, like, why learn Python? There's a few answers to that. A few practical and a few sort of Lambda School answers. One very practical reason is that we want you to be learning multiple languages. As you might have guessed from my work history, I've had to work in a lot of different languages, and not all of them I haven't known all of them to an expert level when I was hired. Part of that is because languages are always changing. Different companies have different stacks, have different technology stacks. You might have a lot of experience with Node and with JS, and then you find the perfect company who you have a really great culture fit with, but they happen to be on a Django stack. And most companies know they don't want to limit themselves, right? They want to have the best developers, and they also know that that the most important thing is to find good developers that they can work well with, that they know have this solid foundation of computer science. And it's not so much that you know a language. However, you should be comfortable learning new languages. This is something you'll always come across. Like when I started working at EdSurge as a Ruby on Rails developer, I had absolutely zero experience with Ruby on Rails. I never did Ruby at all. I worked on a PHP stack with a MySQL database, and yeah, this is a really good graph that Arthur just put in. Python. This is interesting. Overall questions. Is this a Stack Overflow graph? Okay, so this is a good graph. Something like Ruby's not even on here. Sometimes it's like a lot of the questions have been asked, so there's not as many new questions. When there's new things, they tend to grow up a lot. Like, for example, I'm surprised JavaScript hasn't grown more, because things like React have gotten so big in recent years. But yeah, the biggest takeaway from this is that things are always changing. So even if you learn JavaScript right now, like, who knows, in 5 years, maybe no one's using JavaScript, or all right, people will still be using JavaScript, but maybe it's not going to be the latest, greatest thing. And we want you to be able to adapt to the market. One of the idiosyncrasies about working in tech is that things change so fast that you always need to be learning. Always need to be learning new things. Now, that's a little scary, because you're studying so hard, you're working really hard to learn the things that you're studying here, and it's a little disconcerting to know that they may be totally obsolete in a few years. But on the other hand, this is also why those of you who've only been coding for 6 months can compete in the job market, because no one has 10 years of experience with React, for example, because React wasn't around 10 years ago. React was only around about 5 years ago, right? So that's why things like coding boot camps can exist, because there's so much turnover with these languages, and that's why we want you to learn a new language. Another reason that we're doing Python is because it's really fun. It's pretty easy. It's pretty easy to learn, and it emphasizes readability a lot. What do I mean by that? I mean, there's something called the Zen of Python. If you type import this here, this is sort of the philosophy of Python. So beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. So on and so forth. Python really cares about readability. Now that's that has some pros and cons. We're going to go a little more into that when we get into the code. But it makes, since we're going to be going into algorithms and some more complex, some more complex code. And when I say complex, I mean like you can write complex web code, but with nested HTML and like CSS and divs and things like that. But this is complex in how it processes things. It's a different kind of complexity that will take a little bit of time to wrap your head around. And Python is nice because the syntax is very close to English. So one of the ways we're going to go through algorithms is first we're going to talk about, for example, a sorting algorithm. You're going to say, how do we sort this array of numbers? And we're going to start by talking through it. Well, first we want to divide it in half, and then we want to sort with divide it and divide it and divide it, and then sort each one, and then merge the list. That's something called merge sort. And you describe it in English, and then you want to start writing it into code. And it's a little bit of a stretch sometimes to go from describing it in English to writing into code, but Python is very close to English. So it's really good for studying algorithms. It's useful. It's very popular. Again, yeah, by this graph you can see Python's a very popular language. It's used in a number of applications, from not just web and full stack web, but it's also used in AI. It's used in a lot of research in academia. And the code, when you write code, it's because it's easy to read, it's usually easy to maintain. So if you write, you may have had this experience where you write some code and then you come back to it a week later and you stare at it and it's just complete gibberish, right? You have no idea how it works. And Python it's pretty easy to look at it and understand how it works just from looking at it. One comic that I really like to explain Python is this XKCD, where Randall Munro, who is a noted fan of Python, has this experience. Yeah, there's a guy down here who says, "You're flying. How?" He's Python. Yeah, I learned it last night. Everything is so simple. Hello world is just print hello world. I don't know. Dynamic typing, white space, we're going to talk about that. Come join us. Programming is fun again. It's a whole new world up here. But how are you flying? He said, I just typed import anti-gravity. That's it. I also sampled everything in the medicine cabinet for comparison, but I think this is the Python. And this really is the experience with Python. It's super easy to just jump in and start coding. There's not a lot of there's not a lot of crazy syntax. There's not a lot of excess, curly braces and things that you need to know. There's a lot of very, very simple modules you can import. Like actually, if you type in import anti-gravity, it will open up the XKCD comic. This will work in any Python. Just type in import anti-gravity and it opens up this Python comic. So that's another thing about Python. The community is really fun. Exactly. I get high on Python. The community is really fun. And this is something I think when you learn multiple languages, and you go on Stack Overflow, you'll notice different kind of personalities for these different languages. Python is a really fun group. A lot of it, a lot of these people, they hack for the fun and joy of programming more than I guess say Ruby on Rails, which is a lot of like nuts and bolts engineers, who are trying to get different things done. And it's not better or worse, but you will notice different personalities. Um, so when you come to installing Python, there's a little bit of a dark side where um, you're going to be installing Python 3, and this is really important to remember because you do not want to get Python 2 mixed up with Python 3. Like on my computer, I have both Python 2. If I type Python, it installs Python 2.7.10, and when I type Python 3, it installs 3.7. So that's a little confusing, and that gets into the darker side of Python, which is this more recent XKCD comic. So the previous one was written in 2007 by Randall Munroe. This one was written earlier this April, and it's talking about this huge mess of a Python environment. And you might run into a few of these headaches when you're trying to install Python 3. So here you can see there's Python 2.6 versus Homebrew and Python 2.3, all different kinds of messiness. And unfortunately, that's something that you'll have to sort through. Your PMs should be able to help you with some of this, but installing Python can be a little bit of a headache. So yeah. Will you need Python 2 at all? No, you shouldn't need Python 2, but so the reason Python 2 is it comes installed default on Macs, for example, is that a lot of programs use default 2, and they're not backward compatible, unfortunately. So for example, in this 2.7 comic, hello world is just print hello world. That's actually not, if you type in print hello world, you'll get an error. Because in Python 3, you need to put a parentheses around it. And this is something I get tripped up on all the time because I'm used to using, I did most of my Python in Python 2, but it's small things, and you'll pick it up. Yeah, there's different ways to install Python. You can download it and install from source. You can use brew. You can use pip. Yeah, Linux. There's different ways to do it. This is something you have to do with every language whenever you're getting started. And to me, this is the hardest, most frustrating part of coding. I just got a new computer, and I had to reinstall everything, and it's just as painful, the 10th time you do it as the first time you do it. But once you get it done, you don't have to do it anymore, and then you can just enjoy the fun, all the fun of Python. Is there a way to convert 2.x to 3.x from within 3.x before using 2.x code? Yes, I think there's people have written converters. If you look up Python 2 to Python 3, I think they're trying to do a standardized thing where it converts all 2.2 Python 2 code to Python 3 code. But I don't think, because Python 3 is changing so fast, I don't think it's totally foolproof. Which is why there's this mess where you just have multiple environments on your computer. Oh, there is a way. Yes. Import hello. Import. What does that do? Oh, okay. Even easier. You can save 1, 2, 3 characters. Why I recommend Anaconda? I haven't used Anaconda, so I can't give a recommendation. I don't think we're not going to be doing too much heavy duty stuff, but feel free to check out other packages. I would just Google it to see what the pros and cons are. Look at the assignment and see if it'll help you or not. I can't recommend it or not recommend it, having not used it. Cool. So let me see. Um, there's a couple of more links if you want to look for some good examples. Here's this. This is very similar to your homework. I guess if you want to do some examples, these will go through pretty much most of the things in your homework. Um, the homework is to do all of these little files, and these will be going through like making a list, doing hello world. I already showed you the hello world here. Um, going through some data types, importing modules. I'm going to go through a lot of this today in lecture, and but not all of it. So another part of this, when you're learning a new language, is you have to be good at Googling stuff, and you have to be good at looking things up. I don't know about Windows. I haven't used Windows in a very, very long time. So, for example, when you're learning a new language, one of the things that I always forget is how to get the length of an array or the length of a list. For example, in JavaScript, it's like list dot length to lowercase, or is it capital? I don't even remember that. It might be length. It might be list dot length capital. It might be list dot count. It might be length of list. It might be size of list. There's all these different ways to get the length of a list. And when you learn enough languages, like you really can't keep all this in your head. Plus, it might change in the future. So you should be you should be aware of how to Google these things, and it is a skill. Instead of remembering how to get the length of a list in Python, you should just be fast at Googling length of list in Python. It'll be right up there at the top. Yeah. To make Python files, do py at the end. In Python, you get the length of a list by doing len, and it comes out with 3. So that's something nice. Let's go through some other differences between Python and JavaScript. Version. Oh, okay. Yeah, if you want to check your Python version is 2.7. Python 3 version 3.7. So make sure you're using Python 3. Excuse me. So usually they'll have a stable version and an experimental version, and make sure you're using a stable version. But anything with the 3 should be fine. Usually you want the most up-to-date one. Yeah, for JavaScript, there's npm and yarn. Here there's virtualenv and pipenv. JavaScript, you run programs like this. It's very much the same in Python. Okay, so JavaScript, you use semicolons. So the way that you delimit the end of a line of code is with the semicolon, right? So if you want to write some code and you get to the end of the line and then you want to go to the next line, all you have to do is go to a new line and keep writing. As long as there's no semicolon, it'll just keep going on forever. But Python uses whitespace, which can be a little bit tricky. So it uses whitespace, new lines to delimit the end of code, and it uses indents to do nesting. That means if you want to do prints 1, let me open this in the Python files. Oops, so I get some formatting. Sublecture.py. So if you want to do something like print 1, print 2, print 3, you'll notice that these are all on a new line. There's no semicolon at the end. Whoops. Python 3. Print 1, print 2, print 3. No semicolons needed. Now, since all of you have done JavaScript, you may be a little bit familiar with an interpreter. If you go to your code and you can bring up the terminal with Command Option J, right? Where you can do x equals 1, and you can you can run any kind of JavaScript code. So Python also has an interpreter, which you just type by doing Python or Python 3 in this case in your terminal window, and then you can run all kinds of Python code. Now interpreters are great because it lets you test code without having to compile it. If you just want to see how do I do the length of a list, you can do this thing, L123, len L. You can just test some things without having to write a program, write a main function to run it, compiling it, run and executing it. You can just do it straight from the interpreter. Now, Python is an interpreted language, which means it runs with an interpreter. Another word for saying that is a scripting language. So what that means is if you write a program, it'll go through it from top to bottom, one line at a time. This is why you can either run this or you can just copy paste it here. So if you do Python, wrong. Let me save this. Python. See, so when you just run it, it'll go 1, 2, 3. If you declare x equals 2, then you can't put x here because it doesn't get there yet. So this will throw an error. This is something common to all interpreted languages and scripting languages. And it's not too important to remember. Just remember that order matters. One downside to scripting languages is that it's a little bit less efficient than compiled languages, because it needs to compile languages takes all of these things and it runs a lot of things to make it more efficient. But in a scripting language, it needs to read all of these things and then process and turn it into machine code before it runs it. So there is some performance concerns. There's some performance concerns with scripting languages, but nothing that we do now will be too performance intensive. And also Python will take your code, and when you run it, it will compile it into, you might see something called .pyc files that appear magically. Those are compiled Python files where they take your scripted code and run it and turn it into a compiled executable. So Python does get away from a lot of these performance concerns through that. Some other interesting identifiers about Python is that it's a high-level language. It's built in C. Oh, I mean, not necessarily. So right now we're running CPython, and most people run CPython, which means that the language Python is written in C. So this interpreter is C code. All of these things get processed in C and turned into C, which gets turned into machine code. There's different implementations that are written in different languages, which for the most part you don't have to worry about, but it's good to know. Like C is a lower level language, which is funny because before C used to be a high level language over things like assembly code and machine language. But now we consider C a pretty low level language. What else? Python also has automatic memory management and garbage collection, which is really nice. So I saw somewhere at the top of here before the lecture, someone put out this little snippet of code, which is really interesting. So it's true that I'm not sure about C about JS strings, but it's true that Python strings are immutable. And what that means is if you do x equals ABC, and then you do x plus equals DEF, then you're not just appending these together. You're creating an entirely new string. You can test this out by finding where in memory these things lie. So we're using this ID function. So this says where the memory address is, and then if you do x plus equals GHI, and you look at the ID, you can see the ID changes, which means that you're copying over everything into, into an entirely new string. When you get into C later, when you're writing C, you're going to be actually implementing these string functions where you're going to be allocating your own memory and putting your items into the string. So you'll be able to get a new appreciation for all of the fun stuff, all the shortcuts that Python does under the hood. But for now, all you need to know is that when you create this new string, these old strings get thrown into the garbage. So these are still in memory, but they're just, you don't need to worry about them anymore. There's no way to access them. And Python will automatically go and clean up. It's called garbage collection. They're really called garbage collection, where it'll come every once in a while and sweep away all of these unused memories. There's a few, like if you do something like in this example, where you do a big loop where you're continually adding to a string, you can come up with a lot of garbage, and that can fill up your memory very fast. Not fill up your memory, fill up your garbage memory really fast, which means you'll run into some garbage collection. But for the most part, I don't think you'll have to worry about that much. Let's see, what else? Prints. Console.log is just print here. Oh, okay, you can use semicolons if you want to do things in line, but I don't know why you would do that. Semicolons just don't seem much like Python. And here, let's talk about white space. So, as you can see, yeah, with JavaScript, you have these parens and then curly braces. Parens, curly braces, parens, curly braces. And you do the nesting by just nesting your curly braces. In Python, there's no curly braces. So how do you know how things are nested? The way you do it is with white space. And this is something a little bit controversial because a lot of people don't like it. I think it's people who are just used to using curly braces, since JavaScript, Java, C, C++, C#, all these languages use these curlies. So if you're not used to it, it can be tough. But yeah, if you want to do some nesting, so x equals 0, and if x is less than 1, colon. That's the way you signal the end of these sort of parens to curlies, and then you do 1, 2, 3, 4, print less, else, print more. And we can just run this right here. Does not support. Oh, there we go. There we go. Less. If we do 3, it'll print more. So standard is to do 4 spaces. It doesn't have to be 4 spaces. You can do, I think 1 space will work. You can do lots of spaces, and it should still work. The important thing is to be consistent. But like sometimes I just do 2 spaces, but industry standard is using 4, and I think you all should get used to using 4, because if you join, you may think like, oh, I just want to use 2, but if you're joining a company and they say you stick to the style guide, here at this company we always do 4 spaces, you should be used to this. You should also be prepared for a company that says they use only 2, and then you're gonna have to use 2. So just be prepared for that. Another distinction is, so there's a big debate in the computer science world of tabs versus spaces. So some people like to use tabs instead of spaces for things like JavaScript. You can use tabs also in Python. I think my tabs just turned into spaces because of my text editor. You can use tabs, but you cannot mix tabs and spaces. Yeah, that's exactly what I think about too. And if I remember correctly, in Silicon Valley, um, the consensus is that tabs are better, but in Python, um, spaces four spaces is the preferred delimiter. So you should run it like this. And if you want to do nesting, um, if you want to do nesting here, you can see you just put more spaces. Um, functions. Functions work similar to this. So let's do, so functions, you type function name, the arguments, and then a curly brace to signify the beginning and the end. In Python, you do def less than 1, x, let's just make this a function. And it's very similar to the way you define this x clause, this clause. So now we have a function less than 1, 0 is less, more. Pretty simple. Do I recommend Sublime Text over VS Code for Python? This is all a matter of preference. I know that a lot of people now are using VS Code, and there's a lot of cool things that you can do with it. Like, for example, in VS Code, the terminal and the code are all in one. I just use this because I like it, because I started using Sublime 5 years ago, and it still works for me. It also means I have to Alt-Tab a lot, which is probably not the most efficient thing, but I like it. So this is totally a matter of preference. I think a lot of people here at Lambda are using VS Code, so that might be helpful if you want to ask for help and you want a good chance of having someone to answer. I don't know of any Python specific editors or IDEs. The syntax here is just a Python add-on you can include, but these are pretty standard. Like, this is a Python add-on I used for Sublime. I know VS Code has its own Python add-ons, and it just does stuff like coloring. You can automate, like if you do a tab, it turns into 2 spaces, or you can set it to 4 spaces if you want. So this is all really a matter of preference. If you're already using VS Code, I recommend just sticking with VS Code. If you you can use Vim or Emacs if you want, but I guess I don't recommend those too much. Vim is if you want to impress people mostly. I can't think of any other reason why you would use Vim nowadays. I guess if you're doing like embedded stuff, it can be really useful, or really quick edits. But these high level IDEs are pretty much standard now. Okay, let's try to get through a couple more of these, and then we'll take a quick break. Arithmetic operators are pretty similar between JavaScript and Python. There are a few exceptions. So in JavaScript, there's a shortcut of ++ and -, which will increment something by 1. And in Python, that does not exist. So if we have x equals 3, if you do x++ in JavaScript, this would change x to 4. But in Python, that does not exist. In Python, you must explicitly do x plus equals 1, which will turn it to 4. Exponents is nice. If you want to do like 2 exponents to the power of 3, you get 8. So on. Plus equals, I think these are all the same as Python, as JavaScript. One big difference is the way you do and or. So in JavaScript, you do true or false. But in Python, you just put the word or and so on. If you want to do not true and not false, this gets back to the English language readability. So if when you're doing something like if x is greater than 1 and x is less than 1 and x is greater than 10, you do something like this. Oh, this will never happen. X is greater than negative 10. Plus x. Plus x is if you're in an iterator and you want to say, do you increment it at the beginning or at the end? So that it just depends where you put your line here. We'll get into iterators probably after the break. JavaScript's types. All right, types are a little bit of a bigger conversation, so we'll talk about that after the break. Arrays and lists. These are data types. Slices. Yeah, let's talk about this all after. Booleans and conditionals. Yeah, this is what we were talking about before. And, not, or, yes. For loops. Okay, so this seems like a pretty good point to take a break. Let's start this clock. I'll answer some questions, but feel free to go use the restroom, refill your cup of coffee or tea or water, or I don't know if you have enough time to grab a Smoothie King, but yeah, we'll see you in a few minutes. Should you have a virtual env, or is that just for version switching? I think that's a question for here, right? Daniel, to answer your question about virtual env, I don't have a virtual environment set up. I think I tried to install it and it didn't work for me. So I just decided not to. I just decided to punt on that. But what that means is that you just have to remember to type Python 3 every time you run Python instead of Python, just regular Python. Yeah, same here. Actually, I'm going to run to the restroom as well. So let me pause this. All right, 5 minutes is up. Give you a few seconds left to mosey on back. See what is. Let's see if this map has anything to say about virtual M. All right, so let's keep going with Python. Let's keep looking through this JavaScript to Python different sheet. We stopped around. We did some variables. Let's look at some data types. So this week, this is called Intro to Python and Object-Oriented Programming, and we're going to be talking about object-oriented programming a little bit later in the week. Next week is going to be data structures and algorithms, and this is a really big part of what computer science is. And you may be wondering, what is a data structure and what is an algorithm? So if you know, you may have heard that computers are all ones and zeros. Everything is either a 1 or a 0. And that gets to electrical engineering, where you have a semiconductor transistor, and depending on the charge, it'll either have charge or it'll have no charge, which is a 1 or a 0. And they've gotten so small that, like on a disk, it's either one or just series and series of ones and zeros. So given that, how do you turn that into something cohesive? The way you do that is with something called a data structure. And that's a different ways. So you have, like, let's say 32 bits, they're called. And a bit is either a 1 or a 0. And what can you represent with that? And it turns out you can represent a lot with that. With 8 bits, you can have a character. So with 32 of them, you can represent 4 characters, or maybe a color. If you've seen colors that are 255, where each color ranges from 0 to 255, which is how HTML does it. In 32 bits, you can represent a color with a red value, a green value, a blue value, and a transparency value. You can represent an integer. You can represent an integer, which can be from 0 to 2 to the power of 32. An unsigned integer can be roughly 4 billion. And if you do a long int with 64, you can do even more. Now, I'm not going to talk too much about data structures here, because that'll be for next week, where you get to work with Sean. But this is important because I want you to understand the difference between what these data types are. Now, if we look back at this XKCD thing, one of the complaints that the skeptical cue ball head has is about dynamic typing and whitespace. So we talked a little bit about whitespace, and some of the problems are it's not really clear always how lines of code are separated, which once you get used to it, it's actually perfectly clear. But dynamic typing is the other complaint. What he means by that is so in JavaScript you can declare these generic. It's weakly typed, whereas you can give your variables a type, or you can give it no type. And different types are numbers, integer numbers. You have floating point numbers, or you have strings, you have booleans, you have null values, and undefined, which are in Python you have all of these things as well, but nothing has a type ever. So if you do x equals 1, y equals 1.0, z equals string named 1. So these all have different types, but you never declare anything. So I think you may be wondering, how does it know where to store it? How does it know how to store these things? Python uses something called duck typing, which is it's a nickname. I don't know if that's a technical term, but what it refers to is it looks at it makes its best guess at what the type should be. So if you do x equals 1, it says that looks like an integer. If you do x equals 1.0, it's like that looks like a floating point number or a float. If you do x equals 1 with quotes around it, then it looks like a string. And the reason they call it duck typing is because that comes from the saying, well, if it looks like a duck, it sounds like a duck, it smells like a duck, it's probably a duck. It may not be a duck, and there's some cases where that's not correct. But in general, it works. Python also has, if you want to see explicitly what these types are, Python has, let's see, you can do, it's very simple. You can just do type. So you type type and then put a parentheses around it and your variable, and you can see what type it is. The type of y is a float, type of z is a string, and it does this stuff automatically. Now let's say you do x equals 1 and you want it to be a floating point number. So floating point, again, you can just think of it as decimal. Maybe you want it to be a floating point. Then there's something called a cast. So you just type this, and now x becomes a float. So casts are pretty important if you want to make sure that your types are enforced, if you want to get around dynamic typing. Now, this does come up sometimes where, because it means that you have to do a lot of casts in places if you want to make sure your code is safe. And that can make code look a little bit ugly. Excuse me. Which is why this guy's a little skeptical. Like something like C is very strongly typed, where every single variable you declare must have its own type. But Python is, they don't worry so much about that. It's like they're worried more about about trying to get big things done, not about little details like typing every single one of your variables. That's sort of why it's fun. That's kind of why Python is fun. You don't have to worry about so many details. You can look more at the big picture. But it is important to be aware of these types. What else? Strings. There's a few different kinds of strings. We already did string equals 1 A B C. You can either do it with double quotes or you can do it with single quotes. So these are both the same. If you do it like this, you'll notice you print it out. It uses a single quote, even though you declared it with a double quote. You cannot mix them, however. So if you start with a double quote and you end with a single quote, you're going to get an error. Backticks. Do you mean escape? So if you want to do, so if you want to put a quote in there, let's see, like this, it works just fine. But if you do a single quote, this will throw an error. And if you want to put a quote in there, then you use a backslash to escape it. Is this what you're asking, Adrian? Okay. Yeah. So if you're surrounding your things with single quotes and you want to put a single quote in the middle, then you need to escape it. This is called the escape. You need to escape it to show that to tell it like, no, this is not ending my string. This is actually a quote, like a character of quote. If you want to do, let's see, quote equals, Brady said, this is a quote. You'll notice it works just fine because we put single quotes around it. And Python is smart enough to know if you're putting single quotes on the outside, then double quotes are always going to be text. And if you're putting double quotes on the outside, then single quotes are always going to be text. If you want to mix single quotes and double quotes, then you'll need to do some escaping. So if you do something like this, you'll need to escape at least one of them. Oh, that's weird. Oh, why is it? Okay, yeah. If you print it, it works just fine. It looks just fine. How strict is developing in Python? I never confused Python 2 with Python 3. There's minor differences between like 3.3 and 3.6. And if you want to see those, you look at change logs. In general, syntax doesn't change between these versions. So if you write code that runs in Python 3.2, it'll probably work in Python 3.3. But there may be exceptions. In general, you should always try to have the latest and greatest up. But I never really upgrade unless I need to. An exception comes if you're working at a company and you have your code up on the server. Then everyone will want to make sure that everyone is on the same version. So they may say, okay, everyone, when the latest Python came out, I'll make sure to upgrade it. Yeah, Python 2 has major changes between Python 3. So that's something to keep in mind. And I think Python 4 is coming out in the not too distant future. So just be aware of all that. It may make things even more messy. All right, so this is quotes, multi-line strings. If you want to do a multi-line string in JavaScript, you do /* and then close it by //. In Python, you do triple quotes. Multi-line quotes and finish it with triple quotes. This also has a special function here where you do something called a docstring. This will tell if someone wants to know what this function does. The docstring will tell them. This get rid of this. This function tells you if your integer is less than 1. So if you put these multi-line quotes on the first line, it creates what's called a docstring. And that means when someone asks for help, it will return this nice help function. So when you're writing functions, especially when you're on a team, it's good practice to always put this docstring here. Okay. Oh, on the editor. Okay. How's that? We can put this to a new line now. Okay, and that takes us to this help function. Help is one of the most useful functions in all of Python. And there's its friend called dir, which is short for directory. What that does is any single function, any single command in all of Python, if you forget what it means, you can always check for help. So it also works for data types. So like if you have a string equals ABC and you want to see what are all the functions you can do with this string, you type dir and it gives you all of these things. So these are mostly built-in functions, but these are functions you can explicitly call. So like let's say we want to capitalize it, we can do stir dot capitalize, and it'll capitalize it. If you want to, let's see, what else can we do? If we want to see is upper, to see if it's uppercase, right? Is upper, it's false. You can also do help if you forget how this works. Like, so let's say we want to see what is split. You can do help string dot split, and it'll give you this nice doc string that describes it. So this is helpful because it'll tell you the arguments. It'll tell you how everything works. Very similar to a man page. And you can do this for everything. You can do this for every data type possible. Like if you want to do, you can just put the type in manually. So int, and it'll tell you everything you do for an integer, for a float, and so on. Does Python have the template literal functionality of JavaScript? So I think you're talking about string formatting. Is that correct? Where you have a string and then you want to put some code in there. Yes, it does. Yes, it does. Let's see, formats. Format. Okay, it's not here. The answer is yes, it does. And there's a couple of ways to do string formatting, which we, if we get to it, then we'll get to it. But you also have, that's what your printf part from the homework will go over. Okay, so dir and help. Those again are super useful. Anytime you want to know how something works, dir for directory, or help. You can also do help for dir if you want to see what that does. It's like assigning variables to placeholders as in C#. I'm not sure what. Oh, C pounds. Okay, I'm not sure. That is. Okay, string formatting. Oh, it's right here, I think. Python printf string formatting. So yeah, there's two different ways to do formatting. If you want to look here, here is a, I don't know if this is nice, but this is what was linked in the docs. So you can take a look here. There's two different ways to do it. One is with the % sign, and the other is with a dot format. I think that's something I'll leave you guys to Google, because it's pretty easy to look up. Yeah. Or you can just look at that. So there's another way to do it where you do print, let's see, % string, and then % d, % string, and number, and it does the same thing. What else? For loops. So in JavaScript, you would do either for I in A, and you do this, or this in like C or C#, JavaScript, where you do a for blank equals 0. Blank is less than the condition, and then the incrementer, and then the ++ decides what's incremented at the end or at the beginning. Python does this by doing, let's say, let's declare a list. Let's do letters. A, B, C, do for letter in letters, print letter. And it prints all of the letters. So this is really useful. This is something you'll use a lot. So for blank in blank, this can be anything. ASDF doesn't have to be, and it'll work just fine. You want to do this for readability. This is so if you're naming a list, you'll make it plural, and then you can do for singular in the collection and print this out. Usually a lot of times you're doing iterators with a count. Like if you want to do something 10 times, you will use what's called the range function. So for I, for integer or index in range 0 through 10, prints I. Oops. I always forget these parentheses. And it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Keep in mind that the front is inclusive, so we'll include the first element and will not include the last element. This is really useful, and the reason it does this is because when you're doing an array, right, we always start counting from 0. So the first element is not 1, the first element is 0, the second element is 1, the third is 2, and so on. And you have, so if you want to like go through everything in letters, you can do length of letters, print letters dot I, and this should do the same thing. So what this is doing is starting from 0 and it's going through everything in letters and then it's printing it by index. So this is exactly the same as doing this. You also have while loops. So while, let's see, n equals 0, you do while n is less than 10, prints n, and then you need to make sure you do n++, otherwise it'll go forever. Oops, not n++. N plus equals 1. And it'll print the exact same thing. While loops, switch, if, what else is important? Classes, we'll go over that tomorrow. Cool, so I think this is a lot of the basic stuff. Dictionaries are really cool. So dictionaries are also called associative arrays. In JavaScript, they're like objects where you have a key and a value, and the way you declare that is with curlies. So it's d of key equals value, and you see you have this key value pair. And if you want to get the value key, it'll return value. You can also set these to new value. And you can see here, you can also declare d equals this, and it'll come with a key in there. Dictionaries are super powerful. They're an implementation of a hash table or a hash map, which is a variation of a hash table, which is a very, very, very useful data structure. This is one of the most powerful data structures you can use. And when you're coding, this is something you use all the time. So get used to using these. They're also, one of the reasons they're really useful is that they're really efficient. So if you have an array, x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want to see you want to get the value of 5, you'll have to count. So like, all right, is 5 in here? And you'll have to count all the way to get here. So that takes 5 operations. But if you're just doing a key value seek, it happens in constant time, which that'll make sense more when you start doing big O. But just keep in mind, dictionaries are really, really useful. Lists are another very useful thing. Lists are sometimes called arrays, and they're sort of like arrays, but they're not exactly arrays. They come with a lot of unique operations. So let's see what some of those operations are. I'm going to do this. L equals A, B, C. And we have append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. So we can do L dot counts of B, which will say how many B's do we have in there. B, if we add another one. We can do L help L dot extend. How does this? It extends the list by appending elements from L dot append D. L, you can do L dot extend. I think we have to E, F, and we have L. So there's lots of cool stuff that you can do with lists, and these are all pretty efficient. I leave it to you to look through these. There's a couple, like remove and pop are a little bit confusing. Insert and extend are a little bit, insert, extend, and append are all similar ways to add things to your list. And there's some differences with those. I'll leave those to you to look up. Remember, help, L dot inserts to see exactly how it works. So those are lists. Now Python. So we've done lists, we've done conditionals, and we've done iterator loops. So Python also has something cool called list comprehensions, which kind of combines all of these things into one. So let's say for example, we want a list. We have a list of numbers equals. Let's just make some random numbers. All right, so we have this list of, I'll call it X. It's a list of random numbers. All right, and let's say we want to make a list with only the even numbers. All right, so we evens equals multiply an empty array. It would maybe be something like for n and x. If n modulo 2 equals 0, then evens dot append n. And then evens. All right, and then so this appends all of the even numbers, and we didn't do 5, 6, 4, 3 or 4, 7, 3, 5, 3 because those are odd. Again, modulo is the remainder. So how are you going through history in Python for the terminal? Oh, we push up and down. So this code again, it goes through every element in X. It checks if modulo is the same as remainder, so you're dividing it by 2 and then checking the remainder. So in any even number, if you divide it by 2, the remainder is 0. If you divide it by 1, if you divide it by 1, if you divide an odd number by 2, the remainder would be 1. So that's why we're skipping over all of the odd numbers. And this took 1, 2, 3, 4 lines of code, which is not too bad. But Python has a nice way of doing this all in one line. It's called a list comprehension. So that would be evens equals, make sure I remember this. N for n in X if n modulo 2 equals 0. I hope I did this right. Evens. Cool. Evens equals. Make sure it didn't just copy. All right, great. Okay, so this is if you look at everything in this, it's pretty much the same thing we did here. It's just all in one line. And if you think about it in terms of English, we're saying we have a list we're building a list. The square brackets clue you into that, and say we want to put n in the list for all of the n's in x. We can name this better. We can name it nums for n in nums if n modulo 2 equals 0. So this is the format of what we put in there. Right now we're just putting in the number. For n in nums, this is the collection that we're handling, and then this is the condition. So this is the criteria for it being in the list comprehension. Let's say we want to make it into a string. Oops, nums. String object is not callable. What does that mean? Okay, let me do something else. N times 2. Or let's do n plus 1. X should be nums. Where? Line 21. Actually, yeah, I'm not even calling this though. So here. Now we do nums for n in nums if n mod 2 equals. All right. So this is what we want to put in the lists. You can add one, you can do different things to it, or can you do excuse me. Can you do, instead of equals equals, can you do is? That is a good question. The answer is yes, but you shouldn't do it. And that gets into a little bit of the quirk, a little bit of a quirk by Python. So before I get to that, let me just talk through what we're doing here. So you see, we're going through all the numbers and we're putting everything in this list, and then this is showing you how to format it. So we add 1 to all the even numbers in the list. So 676 turned into 677, 234 turned into 235, etc. And if you read this, it's kind of like English, I guess. You can say we're adding 1 and putting it in the list. This is our collection, and this is the condition. So remember that for list comprehensions, start with the brackets and say format, collection, and condition. If you remember these three things, then you should be okay with list comprehensions. They can be tricky, and you're going to have some homework assignments with them, which is why I'm bringing them up. But these can help you save a lot of code. Can you do it? Now, Jameson, to answer your question about is, you can do it, but you probably shouldn't. And the reason for that is because of the difference between is and equals equals. So what is does is it's comparing if two objects are the same. Equals compares if their values are the same, but is compares if their address is the same. Now for the most part, that'll be the same. But if you have something like x equals, this might not work actually. ID x, ID y. Okay, that's not a good example. Let me see, because these actually have the same address. I'm going to give the example that I know very well. X equals 10 to the third power. Y equals 10 to the third power. ID x, ID y. Okay, so x equals 1,000. Y equals 1,000. X equals y. X is y is false. Weird, right? For a lot of, so if you do x equals 10 to the second power, y equals 10 to the second power, x equals y is true, and x is y is also true. Weird, right? So why is that? Yep. Yeah, you got it, Thomas. So the reason, so everything in Python is an object. So that's why everything here has an address. And these numbers, -5 to 255, are, Python knows that those numbers are the most commonly used. So they get put in a lookup table. So they're super efficient to access and to do calculations with. However, when you go outside of 255, which we're doing with when we do 10 to the third power and we get 1,000, then it's creating a new object in memory, and it has its own unique pointer to that object. So that's why when we do ID of x and ID of y, we see that it's different, even though the values are the same. Whereas when we just do x equals y, it's just comparing the values. That's a weird distinction, and for the most part, you don't need to know that. The one time that you do want to do is when you're comparing to none. So if you want to see if something is none, x is none, or x is not none, or you can also do x not is none. Oh, I guess you can't do that. X is not none. So when you're comparing things to none, you want to do is, because none is another thing where you have constant, where you have a constant pointer. Are the IDs of x and y the same in that second example? The IDs of x and y here are the same because they're pointing to 100, and they know that an 100 falls into this range of -5 to 255. Yep, none is equivalent to JavaScript's null. Make sure you have a capital, none versus none. Okay. Are there any questions about that? I know that's a little bit weird, but it's one of the quirks of Python. Equals equals equals. I do not believe that equals 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 does anything. No equals equals equals. That's one of the fun things about Interpreter, is that it's super easy to just test these things, right? You just drop it into here. Okay, slicing. The last thing I want to go over, maybe the last, is slices. So slices are something that you also find yourself using a lot in Python, and they're really powerful and they're really useful. So let's start by making, do we already have a list? Okay, we already have a list here. Now there's a lot of operations we can do with this list, like extend. Let's see, let's look at them all here. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. There's also len. Now it's a little bit weird because len is not here. And len is its own function that takes a list as an argument, but this is another string operation. And slicing is another thing that's similar to that, where slices are not going to appear here, but slices are operations that you can do with lists. So what do I mean by slicing? In JavaScript, I think it's called, oh gosh, I forgot what it is. You have to do subarray or substring, sub something, right? Or is it just slice? Anyway, like say you want to get a subarray. Let me remove one of these b's. L.remove b. Cool. So yeah, again, to get rid of one element, you could just type remove, and it removes the first instance of it, so it doesn't remove all of the b's. It just removes one b. So we have A, B, C, D, E, F. Let's say we want to get some Oh, it's called JavaScript has slice, but it's called slice, right? Like you have to do l.slice, and then it's like 0, 3, something like that, right? In Python, you just use the notation of 0:3, and this will get you 0, 1, 2. So this is similar to our range function in that it's inclusive for the first element and exclusive of the last element. So this will get the first 3 items. If you want to go from 1 to 3, you just do 1 to 3. If instead of 0, you can just put nothing there, and just put a colon, and it'll act as if there's a 0 there. This is similar to the access function. If you don't put any colon there, like if you want to get the 4th elements, you do this. This is not mutating the original string, but it is creating a new string that it returns. So you can see ID of L. ID of L is like this, and if you do ID of L colon 3, we're creating a new element here. And if we call it again, I guess Python is smart enough to know that it's pointing to the same thing. But if we do, also if we do 4, it's pointing to the same one. That's interesting. Wow. Okay, so that's actually, I didn't actually know that. So when you slice multiple times, I think it's probably caching it in memory, but it's taking this extra string, it creates a new one, and then it's giving you subsets of that. So that's super interesting. I didn't know that. But yeah, our original string is untouched. If you want to do start counting from the back, you can do a -1, and that will give you the last element. Oops, not ID. This will give you the last elements here. If you want to go back more, you can do 4 and count backwards. If you do -4 colon, then doing -4 is the same as counting +3. So it'll give you everything to the end. If you want to get start from the second element and go all the way to the second to the last element, you can slice it like this. So it starts from 1, which is B, and then it counts all the way to -2, which is E. And remember, the last element is exclusive, so that's why it gives you B, C, and D. If you want to count from 2 to the end, you can just put an empty space after the colon. You don't even need a space, just do colon, and it'll count all the way to the end. I guess if you just do colon, colon, it'll give you the entire list, but you can just do L for that also. So that's slicing. Slicing is very powerful. Slicing is something that you use really commonly, and this notation I really like because it's super clean. I think that's it about slicing. Tuples or tuples, I don't know how to pronounce that. I changed. I think I say tuples because this looks like it would be tuples, but when I think of tuples, I think of like, I don't know, tuples, I guess. L2. Oh yeah. That's like math notation, right? Where you do inclusive versus exclusive. But so one thing that lists have a lot of different functions where you can change things. But there's another data structure that's similar to lists called a tuple, where you put parentheses around it, 1, 2, 3, 4, and these are absolutely immutable. So like if you have L and you want to change the first elements to 1, you can just do this and you change this. But when you have a T and you want to change the first elements, it does not let you do that. Tuple object does not support item assignment. These are, they just have count and index. So tuples are used because they're super fast and they're super efficient, because they're absolutely immutable. So there's a few instances where these are used for in code. but they're a lot less common than lists for most practical purposes. What else? What did I want to say about these? I just forgot. I lost my train of thought. Sorry about that. Yeah. Oh yeah, one element. This is a weird notation. If you want to make a one element tuple, because if you do this, it will treat it as a parentheses, but you put a comma there to show that it's a one element tuple. Okay, I remember what I wanted to talk about. So in certain languages like C, every item in an array has to be of the same type. So you would this is an integer array. Whoops. X. This is an integer array. X equals Y equals A, B, C. This is a string array. And yeah, that's fine, but each thing has to be the same. One interesting thing about Python with its weak typing is that you can put anything in here. So you can put an integer, you can put a string, you can put a float, and it works just fine. Now this can be a little dangerous, but again, you just need to make sure to be careful with how you assign things. I think that's about all I wanted to talk about with Python. Again, this is your homework. Well, first, your homework is to get Python installed, and then you want to go through all of these assignments. And we've talked about most of these things, but certain things like scope we didn't go over, file.io we didn't go over, objects we didn't go over, and calendar we didn't go over. You should be able to figure out these things by Googling. Or if you really get stuck, ask your PMs, or you can ask me also. Make sure you Google it first, though. That'll help you learn by looking things up yourself. But other than that, does anyone have any questions about Python? Any more questions for me? Any more questions about anything? List comprehensions? Anything you want me to go over before I let you go? Any recommended VS Code extensions for Python? I don't have any recommendations because I don't use VS Code, but I think there's probably a standard thing, just like Python syntax formatting. List comprehensions. All right, let me do another list comprehension. Letters equals, let's do something like names equals Alice, Bob, Charlie. Okay, so we have a list of names, and let's say we want to do some names capitalized. Names equals something. All right, so first of all, we need to know how to capitalize a string, right? How do we do this? We can do help. Oops, help. Oh, that's weird. Help. Oh, I see. So we have upper and capitalize. Actually, upper will capitalize the entire thing, and capitalize will only capitalize the first one. So let's see name for name in names. All right, this is our basic thing. This is a very basic list comprehension that just puts everything into our list comprehension. Now let's say if we want to capitalize it, we just do name.capitalize, and that should work for this. And we capitalize it. Okay, so again, The first thing is a formatting. The second part is our collection, and the third part is our condition. Now, right now we didn't have any condition, but we can do our condition is like if true. We're putting everything in there. Now let's say we only want to include things in our lists that end in the letter E. So for strings, we have this nice function called ends with. Now if we do Alice ends with E, true, and we have Bob ends with E, false. You can have more than one letter in there if you want, but so we only put them in the list if name dot ends with E. So now our list of capitalized names only includes Alice and Charlie, and we exclude Bob because he does not end with E. Is there a begins with? Let's see. There's not a begins with, but there is a starts with function, which works exactly the same. Static typing is something like int a equals 5 and can't be assigned like a equals s. Yes, that's correct. You can achieve that with casting, where if you do like something like I equals int I equals int whatever 3. Does that work? I will automatically cast it, but if you do a, then you get an error here. List comps are like map, reduce, filter. Yeah. List comprehensions are very much like map. It's a way to they're specifically for building lists, and in Python you use lists all the time. They're very commonly used. It's a very powerful and common data structure, so that's shorthand for building these things. And yeah, it does help you filter, map, and reduce. Like when I think of MapReduce, I think of Google because MapReduce is a big thing that they do. But yeah, this is just some pretty clean syntax. I think that's about it. If you import this, I want to close by once again putting up this intro, this Zen of Python philosophy. When your Python is all about writing clean, beautiful looking code, it should be very readable. There's a very big focus on readability. The reason that we use indentations instead of curly braces is because it should look like English. Like if you're writing a paragraph, you group your ideas with indentations, right? You use colons to say to denote that's something that comes after this that has some. The second part has something to do with the first part. You use words like while. We use words like in, for. There's conventions like for, name, in names. So when you're writing Python, try to think about writing very readable code. It's a good test where write your code, step away from it for a day, and then come back and see if you can read it again. You should do that with all of your code. But with Python, I think you'll find that it's a lot easier to jump in and to look at your code and remember what it does and how it works. If there aren't any more questions, I'll let you go. I'll let you all go. Thanks for listening for this first lecture. I hope you have fun with Python, and yeah, ask questions. Please give me feedback on anything I can do better, anything you didn't like, and good luck. Yeah, great to meet you all too.